Now, to create the cutter, our base component was the rivet. So view, hide or show, then origins. We click on this side so that it doesn't place our part yet. We align it to the origin, then we click. Our first component was the arm. So we zoom out, then we place the arm. Like that. So now, when you visualize the handle, you realize that the arm is on the rivet like this. This is how it's attached to the rivet. Like this. So we notice the faces that will be touching. This face will be touching this face. Okay, so we know that that is a coincident mate. So mate, then coincident, because they are two flat surfaces and they are touching each other. So mate. Now we realize that when we do the mate, or when we visualize the mate, we have this face being around this face, and because they are two circular surfaces, we use a concentric mate. So we highlight them, the mate, then we create a concentric mate like that between them. Now we've mated the first arm and the rivet. Now for the second arm, you can duplicate it, holding Alt and then dragging like this. Or you can just insert another component from insert components and insert another arm like that. You can get another arm to place it. Now this arm will be attached to this rivet, but to be the inverted. It will be inverted when compared to this. So in order to visualize it, you just come to this mate. We drop down the mates, then we edit the feature. Either the coincident or concentric. Then we click here under mate alignment. We click anti-aligned. Then it flips it for us. Or let me do it for the coincident mate rather. So for the coincident mate, you click the okay. So this is aligned. I edit and we click the opposite mate alignment. Right. Now it has flipped it. So when you visualize it, even though it's an error, you realize that this face, this will be a little bit down. This face will be touching, or this face will be touching this side of the rivet. The arm will be downwards, but right now with how it is, you realize that this face will be touching this side. So that's how we will do the mate. So we'll come here, then we hide it. Sometimes to do a one mate, you need to hide the component so you can see the other two components better. So we'll do the same concentric mate between the two cylindrical faces. Then this face will be touching this face. It will be flipped. So here's the mate, then click on mate. Then the mate is like this. Then what we do is then we click the anti-align, so it flips it like that. It's giving me an error because I was flipping the other one. Now I'm doing this mate, so that's why it has fixed the error for me. But when you do it, you shouldn't get an error. So I show the other arm. This is how they will be on top of each other, like that. So this, look at the faces that are touching, realize that they're all concentric. Concentric is like if you're at sketch. Let me try and show it using sketch. Front plane, you have two circles like this. Then you have another circle. It's like they have shared the same center. It's like the circles are aligned. That's the meaning of concentric. So that's what we are trying to do with the cylindrical faces of the arm and then the rivet. So I'll hide these components so I can place my blade. Now for the blade, same principle, you visualize it. It's best for you to use the X, Y, and Z rotations, just be playing with it to see which one, so that you can, it makes it easier for mating. So rotate it like this. This is what we want. So now when you visualize it, you know that when you bring it downwards, this is how the blade is going to be on the rivet. The rivet is going to be passing through it like this. So we notice that this inner face and this will be touching. So know that I use not the concentric knot. Then I'll bring the arms inside. I think we need a top arm. There's a top arm that makes contact with it. So shoot. So we have the top arm, then we bring the blade downwards a little bit. Then you notice that the blade, the top surface of the blade is touching the bottom face of the arm. So you know that you are meeting this face and this face, because they are meeting two flat surfaces, two flat faces. So we are using a coincident mate. So that's how you create the mates. That's how you create the mates between the blade and the arm. The last thing we need to do is we need to align the two handles. When you have two components going like this, what you do is select this face, two faces in the same direction. Then you make them parallel. You select mate and select parallel. Apply selections. This face and this face. Like that. Then we'll make them parallel. Now, when we move on, the other should move. So that's it. These are the principles behind the mating of the kata. So in this video, I will be explaining the handle assembly and how you go about mating the various components. So I'm opening a new assembly. Then our base component was the handle. I will send my files, the same files, so you don't need to do the assembly again if you don't have the files. So the handle was our fixed component, our base component. Go to view, hide or show, bring the origin, so that you align the assembly with the origin. So these are our fixed components, we fix it. Go back to view, hide or show, then remove the origin mark. Now the next component was the cap. Go to browse, cap. Then before you click to insert, you can just use the X, Y, and Z rotations so that you get the perfect alignment with the component you're mating with. Now when it comes to mating, you have to visualize like the two components being together. So here I'm going to try and put the cap like this on the handle. When we do this, we realize that this face of the cap and this the inner cylindrical surface of the cap and the cylindrical bottom face of the handle would meet. They will be touching. Now when you are mating cylindrical faces like this, we use a concentric mate. So we'll highlight this face, then we'll highlight this face here. Then when we mate, we will do a concentric mate. like that. Another thing you realize is that the bottom here would be touching the bottom of the handle. Now these are two solid or rectangular faces. They are not cylindrical, they are not curved, they are solid and they are straight, flat surfaces. So when you are mating flat surfaces, we use the coincident mate. So that's how you create the mate, like that. So cylindrical faces, you use coincident mate. Then flat surfaces, you use for cylindrical surfaces you use a concentric mate, and for flat surfaces you use a coincident mate. So you always need to visualize the materials being together, and then you know which type of mate to do. So the next component was the guard. Now with the guard, we learned a new type of mate where you see how for the guard we have a cut here, and then that cut is supposed to be aligned with this cut here. That means their origin should be the same. Now the way of doing this is you mate the planes of the various components. So you come here, you select the handle, we will select the handle, come to this icon here, the eye icon at the top here, then we'll drop down, then we'll click on view planes. Then we'll click on view planes, activate the hide or show primary planes. Then you show the planes of the handle, and then you show the planes of the guard. Now if you want to align them, it's like we've drawn a line, and then the line is passing through them. It's like putting a thread through them, so like they have the same center line and it's passing through them. We'll meet the planes. So we'll meet the front plane of the handle, then we'll meet the front plane of the guard. This is the front plane, the one which is highlighted, and this is the front plane of the handle. So we'll meet them. Then you will look and notice what it does. See, it moves the guard using the front plane, and it aligns their front plane. The mate we use for mating planes is a coincident mate. Now when you mate the front plane, you must mate a plane perpendicular. So you must mate two perpendicular planes. In this case it's the front plane, and then we have the right plane. So we have to mate the front plane and the right plane for it to be like a fully defined mate. That means we've done the sort of the y and x axis, so we mate the right plane as well of each plane. It's the same coincident mate. So you see that the centers are aligned, and that's how we'll be able to put the cutter or the arm through both of them. So I would hide the planes. I'm using a keyboard shortcut, but you can come here and click on hide planes, right here, hide or show, and do it for both of them. Like that. Now when you look at the completed assembly, the cutter is like this. So now we see that we have two faces touching. We have the top surface of the cutter's face here, this one, and then we have the bottom face, this one. These two faces will be touching, and they are flat faces or flat surfaces, so they would be a coincident mate between them. Now to check whether your component is fully defined, you see that it can't move, it's fixed. That means we've defined it in every space. It's not free to move. The next component is the cutter assembly. Now the cutter assembly will just rotate it so that it's easier to use. You can also come to assembly, then using move components, rotate it. So I'll rotate it like this, so it's easier to mate. This makes it easier to mate. Now, what we'll be mating with it, when you look at the full assembly, you realize that this part, this component, okay, it gets better. This component will be going into the handle. To be going into the handle. So we just visualize the cutter entering the handle so that we see which faces would meet. And we'll notice that it's okay like this. You notice that when we visualize it, this face of the cutter will be meeting this face, this inner face of the handle. And there are two flat surfaces, so you create a coincident mate. Once you do one, then the next thing you will need a parallel mate. That means if you have a mate going this way, you need a mate going what? This way to define it. Then when we visualize it, we realize that this part of the cutter will be touching this side of the face, or this inner side of the handle. They are both flat surfaces, so we create a coincident mate between them. So like that. Now we've done this face and we've done this face. This side of the cutter. Now these two are enough to define the cutter. You don't need to come and do this side and this side. You don't need to do that. When you do that, you realize the sketch is over defined, so it's not necessary. So I'll show the other parts. Now the last mate you will need to do is that if you visualize as putting the cutter inside, you realize that this side of the cutter will stop at it will touch the handle like this. So that means we need to create a mate between them. So mating is about the sides which touch, so we'll create a mate between the edge and the bottom face of the handle, because these are the things that will be touching. Then we will create a coincident mate like that. Now we realize that our cutter is fully defined and our guard is fully defined. The only thing which isn't defined is the cap. That's because it can twist. So these are the principles we use in mating. These are the principles we use when we're doing the pizza handle assembly. So now we'll be doing the drawing for the pizza cutter assembly. But first we'll be creating a drawing template. So we'll open any previous drawing we've done, and we'll use it to create a template. So this is the exam drawing template. I have my name and I have the title and everything. So what you do is you come here, the drawing views, then we'll delete all the views like that. Right click, then delete. You also delete the bill of materials, then delete. And we have this. Now think you can create a template where it will have the same views, default views, if you know these are the views you always use. So instead of you deleting all the views like this, maybe you would keep them, and then you will just save it as a drawing template. But for me, the views change, so I always delete it. So bill of materials, you can also keep the bill of materials. So next, every time you do a new drawing, it should just come with it. But for this, I'm deleting all of this, and I'll just keep the sheet because I want the weight, the title, my name and the date to always appear without me doing anything. So I'll come here, save as, or Control S, or File, then save as. Then where it says SolidWorks drawing, we'll change it to drawing templates like this. I already have templates, but that's how you save it. Then you save it with whatever name you want. So now we have our drawing template. You can make this drawing template your default by going to System Options, and you see Default Templates. Then for drawings, browse, you click the three dots, browse, and to give your drawing template here, then click OK to make it your default. And that's how we create a drawing template.